Part Manager is the tool used by Orcad CIS to control the design BOMs and check if all components match the database they came from. We can access the Part Manager by clicking on any component in the object in the design tree and right-clicking and Part Manager. This is the basic structure of a Part Manager tree. The root always shows all the components in the design and the status in reference to the database. In this case, these components were not checked in reference to the database, so they're all marked in yellow, which means they do have a part number, but the part number has not been checked in reference to the database. In this design, we also have components that are not defined in reference to part number, so they cannot be checked in reference to the database, and therefore are undefined by default. Some of them in this case, as you can see, are test points that are not really components, so they do not need any definition. We can divide the design into groups. The groups can be either logical, like the power section, digital section, whatever matches our design, or in this case logical, components that are assembled as common and not assembled will add into a new group called not connected. And see, adding a component to a group can either be done from the design or from the part manager by dragging them into the part group. We will select the test points that we do not need in the design and just drag them into the group. As you can see, they have been removed from the common and placed into the NC group. Now they are still assembled. They are not marked as not assembled, although they are in a new group called not connected. We can mark them as not present by selecting one or more component and pressing not connected. Then we can see it marked as NC as not connected, and the value has been changed. The text written over here is actually set by the database connection file by the administrator. We can all of these are not connected. Now we can check the components we want to assemble in reference to the database. All we have to do is update all parts status. In order to do that, we can click over here and update the whole group. We can do it for a single component, update selected part status, or update all the part statuses. Again, for the whole group. We can do it with this button, update all part status. Just do it over here. Now Orcad goes over the whole design and matches the fields mapped by the administrator in the database connection file to the design, finding the differences. If the difference is acceptable, we can approve it by clicking yes, and the design is automatically updated. In this case, we seem to have a difference in value. It doesn't match, so we can just click no and check it later. In this case, we have a difference, not in value, just in description. The difference seems to be this bracket that we don't really care about. As you can see, we have a progress bar showing us how far we are in the design. Again, a minor difference. There's no real difference in the value. Again, a difference in both description and value. The difference is not a real difference, just a text difference, so we'll approve it again. Source package difference. Source package difference shows us we have a symbol that doesn't match the symbol defined by the administrator in the database. All we have to do is actually go into the design later, place a part directly from the database to replace the existing component, or update the cache with the correct symbol. The difference might only be checksum, that we just opened the symbol in our design and somehow edited it without any changes. Just open it for edit and save. We can click yes or no. The symbol will not be replaced in the design, whatever we click. Warnings have been issued. Every component edited in the design is written in the session log. We can access it at any time, see what was changed, what was updated, what was not updated. Everything is listed over there. You can reference it whenever you want, not now. BOM variants. BOM variants enable us to create more than one BOM from a single design. In this case, we need only one BOM, but we want to make it show us which components are assembled and which are not. We create a new BOM variant, give it any name you want, in this case ASCII, and drag groups into it. Most of our work usually is done in the groups, but we have to build the assembly. Common components are always assembled, so you put them in the group. Not connected components are also assembled. As you can see, the ASCII contains all the components, including the not assembled components, and there are no special marks over here at the moment. If I remove a group from the BOM variant, and not all the components are listed in the BOM variant, we'll get question marks. This will disable the option to extract a BOM from the design under this BOM variant, because we don't have all the information required. We don't know what to do with these components. If we add the components, everything is okay, no question marks. We can extract the BOM, clicking with the bill of material. We can select the core design or the ASCII bill of material and extract a BOM according to what we need. We'll not do it now. From the design itself, we can not see what is assembled or not assembled at the current view. What we can do, for instance, if we want to add a group of components into a BOM variant, into a group actually, we cannot do it to a BOM variant, we just work with groups. I selected a few components and I want to add them to a specific group. Just right click on them, add parts to a group. The not connected group in this case. If we have more than one group, we can select more than one and add the components to more than one group. They actually have been moved, not only added, just they moved because they were in the core design, in the common components. They have been moved from the common components. Let's, for instance, look at J3. It was in the common parts, and now J3 is no longer here. It's been moved to the NC group. They are still connected, but we can change that. So right click, set parts is not present, set all of them is not present, just for the example. As you can see, we don't see anything in the design, nothing has been changed. We don't see components that are not connected. Now we have to show that by clicking View, Variant View Mode. This will save the design, so if there's any question or any problem, make a copy before you do that. We'll select the ASCII variant, save the design. The part manager is closed because we do not have the ability to change anything in there. As you can see, the components that are not connected have changed color, and the value, the text info, has been changed to NC as set in the DBC connection file. When we are in variant view mode, we cannot move any component, we cannot do anything in the design. It is locked for editing. In addition, if we look at the title block, and we have added a variant section in the title block, we get the variant name. You can now go back to the core variant, to the core design. This is the field name, and the components are back to normal as though they are still assembled. That's it.